Happy morning to all. This is Saranya, Assistant Professor, Department of Computer Science from Dr. SNS Rajalakshmi College of Arts and Science. Today we are going to see a lecture series in the topic Finite Automata and its types in theory of computation. So the word theory of computation, theory means it's none other than set of ideas. We are going to give some detailed explanation of something, some concepts. Computation, the word computation is none other than calculations or solving problems. So for that we are going to implement some set of techniques. So normally in theory of computation we have three branches. One is theory of finite automata, and then theory of computability, and then theory of complexity. So these three branches comes under theory of computation. So first let us see what is meant by finite automata. The word finite automata is none other than automata theory. Automata, it's closely related to the word automaton. The automaton is one of the scientist name. So it's none other than machine. Automata, the word automata is none other than machine. So it's also known as theory of computation. It's a theoretical branch of computer science and mathematics. Mainly deals with logic of computation with respect to simple machines referred as automata. So in that finite automata, we have two different types. One is DFA and another one is NFA. So DFA is stands for deterministic finite automata. NFA stands for non-deterministic finite automata. Finite automata deals with set of transitions, set of states, and then discrete inputs and output. Usually finite automata consists of 5 tuples. One is Q, and then sigma, delta, Q naught, and then F. So with this we are going to calculate and we are going to find some new techniques in order to solve some problem. So first let us see what is meant by deterministic finite automata. Deterministic finite automata is referred as uniqueness of the computation. In DFA, machine goes to one state only for a particular input character. And also DFA does not accept the null move. It is very difficult to process when compared to NFA. Next, let us see what is meant by NFA. NFA stands for non-deterministic finite automata. It is also one kind of finite automata. It is used to transmit any number of states, multi number of states for a particular input. So it also accepts the null move. So that's what the NFA with epsilon transition is accepted under non-deterministic finite automata. Non-deterministic finite automata compared to DFA, it's very easy to solve some complicated problems. Then the types of finite automata can represent in three ways. One is transition diagram, another one is transition table, and then transition function. So these three ways we can able to represent the finite automata. So transition diagram means it's none other than state transition diagram is a directed graph which can be constructed with the help of a node. Each node in Q we are going to represent by single circle. And also there is a directed edge from node Q to node P labeled as delta Q comma A is equal to P. So P is a productivity rule. With the help of delta, we are going to make the transition function from one state to another. Start state usually denoted with the help of arrow symbol, and then accepted states or final states are indicating by a double circle. So these are the notations represented here as simple notations we are going to use under finite automata. So Q1 usually state, it's going to represent with the help of single circle. Arrow symbol, it's none other than transition from one state to another. And then start states and all represent with the help of single circle Q naught. Q naught dash is also can represent for start state. And then final state we are going to represent with the help of double circle. So next, transition table is basically a tabular structure, tabular representation of the transition function. It takes two arguments, one is state and another one is symbol. It's going to return the next state. So table can be represented with the help of transition diagram and also function. Transition function is a mathematical function in order to denote the transition process from one state to another. In order to solve some technical problems, we can use these representation in order to solve some technical problems. So thank you guys. If you have any queries, please contact me. I will help you relevant to finite automata in theory of computation. Thank you all for your patient listening. Thank you.